Hello. Oh, there we go. Kia ora koutou. I'm Sam Watson. I'm a platform developer at Runaway Play, where I've been for 5 years after finishing my Bachelor of IT at Otago Polytechnic. Runaway is a nature-based game developer and publisher in Dunedin, where we have 7 mobile games, and just recently released a game for Switch and Steam. I mainly work with the servers, the databases in our backend API. I'm going to be talking about how I built an OAuth2 authorization server and how we customized it for mobile games. For a long time at Runaway, we've been basically battling with external login systems. The main system we used was Facebook, and there was always some SDK change or random requirement that prevented us from using it easily and smoothly, and it's only been getting harder for us to keep maintaining it. Since we use Facebook as a login option, Apple requires us to also support their Apple login, which is more straightforward to use than Facebook, but is still a pain. By building our own login system, it means we don't have to use Facebook and Apple to log in. We can just support the one login type and we can control it. About 2 years ago, it all came to a head and the decision was made that it was time to start working on our own login system. I was assigned with this and I had no idea where to start. I knew I was likely going to use Python and use Flask as the web server, as those were where my experience was, and to continue using the well-supported languages and frameworks that we've already used in our previous projects. I did a lot of research into different authentication methods and types and settled on using OAuth2, mainly because it seemed to be the most popular and the most supported with lots of guides and documentation and an easy-to-use Python library called Authlib. I had no idea about OAuth2 outside of adding a Google login to our internal management website. So I spent about 2 weeks finding out all about it and figuring out what parts of OAuth2 were relevant to what we wanted to achieve with a login system. This is where I found out that what I was wanting to build was an authorization server. Once I figured that out, I started drawing up flowcharts to work out how it would all work together. This was the main flowchart I drew to figure out the most basic way the system would work. We settled on this flowchart where the game is opened, the player clicks on a button that says login with Runaway, they enter their email, go to their email and click on a confirmation. The player goes back to the game and the game logs them in. So you can see what I mean. This is how it works in a game. So after all the research, I came to a decision that I was definitely going to use Flask as the web server framework. Flask SQL could be for the ORM, and a well-supported library called Authlib was going to be the best way to handle the OAuth2 parts of the system. I'm not going to go into any huge detail about Flask and Flask SQL Command, but if you don't know what they are, Flask is just a web server micro framework. It's super easy to use and easy to customize, and we use it for APIs. Flask SQL Command is the object relational mapper layer between the database and the Flask app. All of our databases at the moment are Postgres relational databases, so Flask SQL Command makes it super easy to the databases and perform queries. Before I get into what an OAuth2 authorization server is, I'm going to go over some of the names of different services and parts of the whole Runaway infrastructure that I'll be referring to. For the Runaway login service, there ended up being 3 parts, including the authorization server, all named after different species of sea turtles. Since Runaway makes nature-themed games, we usually name our projects after various animals. So Loggerhead is the authorization server, named because log is in loggerhead and it's in login. Leatherback is for the profile management service, named because it's the back end and back is in leatherback. And Hawksbill is the front-end web app for Leatherback. It's a profile service that can log into to manage their profile. Named Hawksbill because bills are usually on the faces of animals, which is usually the front, and this is the front end. The other parts of the infrastructure that I'll be referring to aren't named after turtles or anything cool. One is just the admin portal, which is the internal management website that was specifically built for Runaway, so we can manage everything in the main game database. The platform API is the API service that every game uses, and it handles literally everything from game saving to game logging in to keeping track of daily active users to letting a player add friends and send gifts to them. The last part I'll be referring to is one of our games, Birdkind. It's our latest game, and it's the first to have Runaway login added into it. So what is OAuth2? It's a framework that lets applications use user accounts on an HTTP service by delegating user authentication to a service that hosts user accounts. The service also authorizes third-party apps to access the user accounts. So think of any website or app that has the option to use Facebook, Apple, Google, any other option to log in. That's OAuth2. In OAuth2, there are roles that we need to know about. To try and explain that as simply as possible, I'm going to relate them back to those parts in our infrastructure that I was talking about. The first one is a resource owner, which is just the player that's logging into Birdkind. The next one is a client, which is the application the player is logging into. So they're logging into Birdkind. And finally, we have two different servers, a resource server and an authorization server. A resource server is where the protected resources are. So in this case, we have two of those, being the platform API and Leatherback. The authorization server is named Loggerhead, and an authorization server is the server that verifies the identity of the resource owner and issues access tokens to a client. And this is what we'll be focusing on today. For this to be an authorization server, we need to know about the 5 different types of authorization grants and make a decision on the ones that we want to use. The authorization grants are just different ways of letting a player or a client gain access to the information stored in Leatherback or the platform API. In Loggerhead, we support 4 of the 5 grant types, and these are authorization code, resource owner password credentials, refresh token, and client credentials. The 5th grant is an implicit grant, which is used when there's an endpoint that's a public endpoint and doesn't need a client secret or an access token. We don't have any endpoints that are public in this way, and we don't have plans to have any endpoints like this. So I made the decision not to use this grant type. In a game, the main grant type that is used is the authorization code. This grant works by the player entering their email address, confirming their email, and then the authorization code gets generated. And then the player goes back to the game where the game has grabbed the authorization code and it gets exchanged for an access token and a refresh token. A game can also support the resource owner password credentials and refresh token grant types too. For the resource owner password credentials to work, in our case, the player has to have already used Runaway Login before and gone into Hawksbill to set up a password. When the player goes to log into a game, they enter their email address and password, and Loggerhead returns the access token and refresh token. The refresh token grant type that's returned when the game uses a token that's returned when the game gets the original access token. This means that when the player returns the game for a new play session, they can be logged straight into their game without having to go through the whole authorization code process or enter their password every time. The final grant type is the client credential grant type. This grant keeps track of a client ID and a client secret to give our portal access to Loggerhead and Leatherback so we can manage the players' accounts and registered clients. The Authlib docs have a great starting guide on building an authorization server, and I followed the guide pretty closely and only made a few small changes to better fit our use case. A great part of Authlib is I've got a bunch of classes and functions we can import into our code to build the system. To get Authlib set up, we have to make some database models with Flask SQL. The first 2 models we're going to set up are the resource owner and the client models. The resource owner in the guide is a model named user, but we wanted to stick to terms that better match our use case, so this is a player. For the other models, there's a mixin class from Authlib that we can inherit, but for a user/player model, there aren't any mixins to inherit. We can make it do whatever we want. All Authlib requires is one model, and it's get user ID. The method just grabs the user ID, which in our case is a player ID. We made the player ID be the player's email address and the primary key, so we had an easy built-in way of making sure there aren't repeat addresses that get registered. We have another field called account ID, so we're not using the email address as the main ID that gets used as a foreign key in other tables. I kept the client named as a client, seeing as there's a few places other than games that use loggerhead, so calling it game wouldn't make sense. Authlib has a client mixin class we can inherit, so we don't have to do a ton of work to get it going. The mixin handles all of the field definitions, including the client ID and client secret, so we just had to add a name field so we could have a human-readable name for a client. So now that we have the client and the player models, we can get to writing the other two models that Authlib needs. The model for an authorization server is, for an authorization code is pretty simple. Thanks to the mixin, we can inherit. We just need to tell it about the player ID and the relationship to the player model. There's also a model that keeps track of access tokens called token, and there's another mixin from Authlib we can inherit for this one that handles all the functionality the model needs. Once again, we just need to tell it about the foreign key relationships to player and client, as mixin doesn't handle that. Since we're using a player as a class name instead of user, the user ID field becomes player ID, and it means we just have to have a getter and setter properties for user ID so Authlib doesn't freak out later. Before we can get into the fun part of writing the endpoints, we need to get the configuration all set up. In this file, we're basically instantiating an authorization server class that Authlib has, telling it about which grant types to use, how to grab IDs and codes, and our models, and it all gets set up as part of the Flask app factory and a Flask app config. We're going to set up the grant types first, and we need to tell Authlib how to handle the authorization code, refresh token, and password grants. For each of those three grants, we create a class and inherit the corresponding subclass and implement the methods that Authlib asks us to. The authorization grant is the most complicated, so we'll start with that one. We have 4 methods we need to implement. Save authorization code handles the creation of a new code in the database model. Query authorization code has the code that handles the ORM query to the database to grab the object of the given authorization code. I don't think I need to explain what delete authorization code does. It just deletes the code after it's been used. The authenticate user uses the player foreign key relationship on an authorization code object to grab the object of the player it belongs to. We also need to tell the grant what kind of auth methods it can use to validate the client and a request to the server. Client secret basic means we use an encoded value in the authorization header of the request, and client secret post means we track the client ID and encoded client secret into either the URL parameters or the post body of the request. The password grant is heaps simpler. It has less requirements to implement, so we just need to tell the grant how to authenticate the player, which is pretty simple. We just need to grab the player object from the player ID, check that the object isn't none, otherwise there's no player there, and that the password we've been given matches what's in the database. All the checking password work happens in a method of the player model, so it makes method even easier. To be able to use the refresh token grant, we have to implement 3 methods. Authenticate refresh token, authenticate user, revoke old credential. Authenticate refresh token just does the work to make sure the refresh token is legit and active. The authenticate user just grabs the player object from the relationship to the token object that we're supplied with. And revoke old credential sets a Boolean field on the refresh token object called revoked to true and saves it. We also need to create a class constant called include new refresh token. So when the response is created, it returns an access token and a refresh token. So the next time the player starts a new play session, they can be logged straight in. If we don't set that, the game doesn't get the new refresh token and the player will have to do the authorization code or password login again. Now that we have the grant set up, we need to set up the route decorator and the instance of the authorization server class we'll be using. The require OAuth decorator goes on to every route function that a player needs to be logged in for. It handles all the work to make sure the request object has the access token in the authorization header before we start doing any work. So track them out if the token is wrong. Later on in the routes, we need to use the methods that we get from a class in Authlib called Authorization Server. This class is what turns all this work from just random code into being an authorization server. To do the first setup of the class instance, we give it the helper functions of create query client func and create save token func from Authlib, so it has functions to query a client and save a token. The last part of the config file is a function I made to be imported to our main Flask app.py file, so it can be all set up as part of the application factory. The first 4 lines of the function are just registering the grants we created to the authorization server instance. After the grants are registered, we need to tell the authorization server instance how to revoke a token, tell the require OAuth decorator how to validate a token, and then initialize the Flask app to the authorization server. So we've got all the models and the config all sorted. We just need to write the routes. This is a bit that's the most fun because we get to see the result of all the work that we just did with the models and config. There's 6 endpoints we're going to go over, and I'm going to talk about them in the order they get used, so each route is dependent on the route before it. To kick off the player logging into a game, OAuth/login is hit when the player enters their email address. It's a GET, so it needs the email address to be added to the root query. When the root gets called, it also needs to have an encoded client ID and client secret in the authorization header in the request. This function checks if the player exists, and if it doesn't exist, we check the email address is valid, and then we create a new player database record. Once we have a player object, either an existing one or a new one, we create a UUID code so we have an easy way to know that it's a legit email link so we have an easy way to know that later on when we have an email to send, that the link that we send is a legit one and hasn't been used before. We send the player an email and return the player ID, the client ID, and a boolean if the email was sent back to the game. The next endpoint that gets hit is OAuth/authorize. This is the link that the player hits when they open the email to confirm it's them logging in. When the player clicks the button, the authorization code gets generated, and the player gets redirected to a page in Hawksbill. This can only be a GET, seeing it's used in a button in an HTML email query, and it means we just have to chuck a bit of information into the route query. The client ID and client secret are to confirm that this is coming from a legitimate client, and the OAuth equals code is the unique code, this is the unique code we generated during the OAuth/login. For the authorization code that we need to generate, Authlib has a method for it as part of the authorization server class. And I've just lost myself completely. It generates the code, and then the code gets tagged on to a redirection endpoint. So for the endpoint that does the work when the player gets redirected into Hawksbill, it's just called confirmed, and it's a post. The endpoint, it gets called as part of the Vue front-end JavaScript. When the OAuth/authorize returns the redirection, it tacks on that authorization code to the confirmed URL, and we use that code to confirm the player has done everything to check it's them logging in. And the post body for the request to confirmed is just the authorization code. When the player goes back to the game is pulling an endpoint called getCode, which is just a post, and it sends the player ID along with the client auth header to find the authorization code we just generated. And it sends the code back to the game. The route returns a none value until the authorization code is found. The game then exchanges the authorization code for an access token by calling OAuth/token. This route is the easiest to code up, but it does the most work. So we just have to define it, make sure the client auth header is legitimate, and then return the token response method that's a part of the authorization server class. This endpoint is used when we have a refresh token to exchange or password and email address. The endpoint is a post that requires form data rather than JSON data, and to be able to use any of the 3 grant types, a grant type field has to be part of the form data, as well as either the email and password, refresh token, or authorization code. The final endpoint we need for this to be an authorization server is the revoke endpoint. This one is similar to the token endpoint in that we just have to define it and return the method of the authorization server class to revoke the token. This just like logs the player out when they hit the log out on their game. And that's it. Those are the main requirements to get OAuth2 authorization server running. To recap, we wrote 4 models called player, client, token, and authorization code. Figured out what grant types to support of authorization code, refresh token, resource owner password credentials, and client credentials. And wrote the code to register them to the authorization server instance and configure the instance. And then we write the endpoints that the games use so players can actually use the system. And just to see it again, this is the result of all that work that we did. So Burkine was released last week with Runaway Login as a login option, and it's been going really well. We've had about 1,500 people log in using the system out of over about 10,000 daily users for the last week. The other thousands of people have either logged in as a guest or logged in with their Apple ID. We didn't have any targets or goals for how many logins we wanted to get, but 1,500 logins is more than I expected. Everything has gone smoothly with the launch in regards to Runaway Login, so it couldn't have started off better. The end goal is to get the system into all of our games and take out Facebook altogether, so it feels like it's been a good start. If you've got any questions, feel free to come and ask. I'll be around for the rest of the weekend, or get in touch. Thanks.